Now what would be the focal length when two lenses, the thin lenses, are in contact with each other, as shown in figure? A and B lenses are in contact with each other. These lenses are thin lenses. You can measure the distance from point P. Object distance is U, and image distance, we have a two different image distance. Because of what? Because we are considering image formed due to two different lenses. So here, for the first lens A, you can see the rays which are refracted and forming the image at I1. So what would be the formula for the same? That we'll discuss. What happened for lens A? Here you can see, here we have an intermediate image distance, that is V1, object distance is U, and focal length of A, that is F1. Here we have an intermediate image. Now this intermediate image is a real image because of A, that would act as a virtual object. That would act as a virtual object for lens P. So here your object is at what distance for B? It is at V1 distance, and image due to B is formed at I. The final image is formed at I, which is at distance V from the point P. So what would be the formula for lens B? Here the object distance is V1, okay, and image distance is V. Now you can add this to equation 1 and 2, you will come to this expression. Okay, now instead of taking these two lenses, if you have a single lens whose focal length is equivalent to the focal length of this system of two lenses, in that case we have a normal formula, 1 upon V minus 1 upon U, that is equal to 1 upon F. Now you can compare equation 3 and equation 4. Left hand side is same, so the right hand side should be same. So here we will obtain the expression for the focal length of system of lenses. When you are having a two lens, then you will have to take the reciprocal sum of two focal length to get the reciprocal of the focal length. This relation is very much similar to the resistances connected in parallel. अगर रेजिस्टेंसेस को आप पैरेलल में कनेक्ट करते हो तो जैसा फॉर्मूला आता है वैसा ही यहाँ है. If you are having more than one lenses which are in contact with each other, and this lens is necessarily a thin lenses, so we'll have this expression, 1 upon F is equal to 1 upon F1, F2, F3 and so on. And you know very well that power is a reciprocal of focal length. So here you will get power directly by addition. Total power you can get directly by addition of power of each lens. So this is the relation for the power. Now what about the total magnification because of two lenses? Magnification is simply ratio of image distance to the object distance. If we divide by V1 and multiply by V1, then what we will get, V by V1, that is a magnification due to lens B, that is lens 2, and V1 by U, that is the magnification due to lens 1. So you will get the total magnification as product of magnification due to each lens. Look at the illustration 9.8. What it says, if focal length is 0.5 meter, then what is the power of lens? Okay, this is the first question. You can answer quite easily. Power of lens is simply reciprocal of focal length, 1 by 0.5, that is 2 meter inverse. But you know the unit of power of lens is diopter, so it is in diopter. Now radius of curvature is given. One is 10, another is 15. If one is positive, then another obviously negative. If you are using this formula, 1 upon f n minus 1, 1 upon r1 minus 1 upon r2, in that case you substitute the values. Focal length, since it is a convex lens, f is 12 centimeter, r1 10 and r2 minus 15. Okay, if you simplify this all, then you will come to n is equal to 1.5. So this is the second question. What is the third question? A convex lens has a 20 centimeter focal length in air. What is the focal length when it is in the water? When you are immersing this convex lens in water, what would be the focal length? To find out that, if we consider the first case of air, in air N2, refractive index of material of prism is 1.5, refractive index of air is 1. Substitute all those. R1, R2 are non-known to us, focal length is known to us 20 centimeter and all. We will come to one expression number 1 with this substitution. When you are immersing in liquid, then medium in contact with the lens is no longer air, but rather the medium is water. So N2 is 1.5, but N1 is not 1 but 1.33. Substitute all those and you will be able to find out what? You will be able to reach the expression number 2. Simply substituting the value. FW is not known, mind well. You should not take that equal to 20, but it is to be found. Okay, so we'll come to the expression number 2 with the substitution of N1 and N2. Okay, now you can see equation 1. Equation 1 contains R1 by R2. Equation 2 is also containing the same. So if you take the ratio of these two equations, dividing equation 1 by equation 2, then R1, R2 will cancel. And remaining is FW 1.33.70 multiplied by 10, and you will get your focal length of lens in water. You can see the focal length increases while you are immersing the convex lens in the liquid. Its focal length increases.